Welcome everyone to today's Explainer. So whether you're a student currently tackling your Class 10 social studies syllabus or honestly just a curious mind wanting to understand the natural world a bit better, you are in the exact right place. Today, we're going to decode the absolute mysteries of India's climate. We'll be exploring everything from the everyday weather right outside your window all the way up to the massive continent-sized monsoon engine that literally drives the agriculture for a billion people. It's a fascinating journey, so let's jump right in.
Here's our roadmap for today. We'll start by breaking down weather versus climate, then move into the 4 climate power factors, explore India's summer, winter, and rain, dive deep into the mighty monsoon engine, and wrap up with the reality of anthropogenic global warming. All right, Section 1, Weather versus Climate. Now, you might be wondering, why is it that when you turn on the news, the anchor gives you a daily weather update, but they never give you a daily climate update? Well, let's dive into this, because the distinction here is absolutely foundational. Weather is simply a short-term estimation. It's the daily atmospheric conditions. What's happening outside right now, today, or maybe this week? Think of it like your daily news update. Climate, on the other hand, well, that's the long-term average of those exact weather conditions, but measured over a massive span of 20 to 30 years. So if weather's the daily newspaper, climate is the 30-year history book of a region.
And the actual tools scientists use to build that history book, it's called a climograph. Instead of just kind of guessing the daily temperature, geographers use this to track average monthly temperatures and conditions for specific places over 10, 20, or even more years. By looking at a climograph for a city like Hyderabad, Vijayawada, or Warangal, we can instantly assess the true long-term climatic condition of that location for any given month, rather than just relying on a passing rain cloud to tell us what it's like.
That brings us to Section 2, the 4 climate power factors. Let's look at the geographical rules that basically command and control the climate. There are 4 main mechanics at play here. First up, we've got latitudes, which is just how far a place is from the equator. The sun's rays hit the equator directly, giving places like African nations really hot climates. But as those rays travel further toward the colder poles, they lose solar radiation, creating moderate or cold climates in places like, say, Canada. Then we have the land and water relationship, relief, which is elevation, and finally, upper atmospheric circulation. Let's look a bit closer at these. So consider the makeup of the Earth's surface. Nearly 70% of it is water, leaving about 30% is land. Now, water has a very unique nature. It heats up slowly and it cools down slowly. This is completely unlike land, which heats and cools super rapidly. Because of this relationship, coastal cities near water bodies like Chennai or places in Kerala enjoy a wonderfully moderate climate. The water just absorbs all that excess heat. Meanwhile, interior regions far away from the coast, like Hyderabad, face far more extreme temperature fluctuations.
Have you ever wondered why hill stations like Shimla, Nainital, or Ooty are so amazingly refreshing in the middle of a sweltering summer? Well, it's entirely because of this relief factor, the high elevation cooling effect. For every 1,000 meters you go up in elevation, the temperature drops by exactly 1 degree Celsius. So if you travel up 3,000 or 4,000 meters into the mountains, the temperature can be a full 4 degrees cooler than the plains down below. The physical landforms themselves literally dictate the climate.
The 4th power factor happens way up high above our heads. Jet streams are extremely fast, high-altitude, cold winds that originate in the subtropical regions. They rush toward the equator with a massive amount of force. When these powerful atmospheric rivers crash into a region, they drastically alter the local temperatures of the areas they pass over, cooling things down before reversing and moving off to change the climate somewhere else.
Okay, moving on to Section 3, Summer, Winter, and Rain. Now that we've got a handle on the 4 power factors, let's see how they actively create the distinct seasons in India.
Let's trace the chronological arc of India's seasons. Winter runs from mid-November to February, with January being the absolute coldest month. During this time, North India can literally freeze, with temperatures dropping below 10 degrees or even hitting negative numbers. But because of that land and water relationship we just talked about, South India's peninsular water borders keep its winters wonderfully moderate, hovering right around 20 degrees. Summer then kicks in from March to mid-June, which is followed by the highly anticipated monsoon onset.
During that really intense summer block, specifically in April and May, things get extreme. The northern and central parts of India are blasted by what are called Lu winds. These are dry, scorching hot winds that push average temperatures well past 30 degrees, and sometimes up to 42 degrees. In localized areas, like the coal mining regions of Ramagundam, the local geography can actually trap that heat, pushing temperatures up to a staggering 48 degrees Celsius. No way around it. That is hot. But right before the real rainy season begins in June, something pretty wonderful happens in the southern peninsula. As the northwestern winds begin to shift, they bring pre-monsoon rains to regions like Andhra Pradesh. These are beautifully known as mango showers. Why? Because they fall right during the ripening season of mango plantations, helping the crops sweeten and spreading a really delightful fragrant scent across the fields. It's a perfect example of how local weather directly impacts agriculture and culture.
And that brings us to Section 4, the mighty monsoon engine. This is, without a doubt, the most crucial season for India's agriculture, and understanding it means we have to look at a massive transformation of winds.
9 kilometers. That is the towering elevation of the Tibetan Plateau, which is often called the roof of the world. And honestly, this brilliantly illustrates our next point.
Because the Tibetan Plateau is so incredibly high up, when it experiences the extreme heat of the northern summer, it dries up and forms a massive low-pressure vacuum. This acts like a giant atmospheric magnet. It literally pulls high-pressure, moisture-heavy winds all the way from the Indian Ocean. As these pulled winds rush toward India, they split. One branch hits the Arabian Sea, crashing into the Western Ghats and showering the nation. The other branch sweeps up through the Bay of Bengal. It is a stunning mechanical process of nature.
But, as they say, what goes up must come down. By October, the cold winds that brought the rain have warmed up and settled over the lowlands, creating a sweltering period appropriately known as October heat. The high pressure returns, and the winds actually reverse direction in a process called the retreating monsoons. Unfortunately, as these winds pull back across the Bay of Bengal, they pick up moisture and form severe depressions. Every single year, without fail, these retreating winds bring devastating cyclones that strike the eastern coast, causing massive damage to the Krishna, Godavari, and Kaveri deltas.
Let's zoom out to the macro scale for our final section, anthropogenic global warming. We need to shift our focus to a modern, existential threat that is actively changing the very weather systems we just mapped out.
Now, this is a critical vocabulary term for your syllabus, anthropogenic global warming, or AGW. Anthropogenic simply means human-made. Through the Industrial Revolution, mass deforestation, and the release of greenhouse gases like carbon and methane, humans are fundamentally altering the globe. These gases deplete the protective ozone layer, which usually shields us from harsh UV rays, and they trap heat, warming the entire planet and melting ice caps at a rapid pace.
Recognizing this crisis, global governments formed the IPCC, the Intergovernmental Panel on Climate Change. However, at their 2013 meeting in Warsaw, Poland, a massive stalemate occurred. On one side, developed nations, who emit high amounts of carbon, refused to significantly cut their current emissions. On the other side, developing countries argued that they absolutely need to utilize carbon emissions to build their economies and achieve political stability. Neither side has been entirely willing to compromise, which highlights just how incredibly complex international climate politics truly are.
So, to put this into perspective, an average global temperature rise of just 2 degrees Celsius might not sound like much. You might think, oh, it went from 38 degrees to 40. Big deal. But on a global average, just 2 degrees is enough to melt polar ice caps and raise global ocean levels by an entire meter. That is massive.
And to ground this science in reality, we don't really have to look far. When average sea levels rise, coastal communities are put in immediate danger. Take Supercyclone Isla back in 2009. Because of the intense thunderstorms and rapidly rising waters on the eastern coast, authorities in Kolkata literally had to use bulldozers to knock down vulnerable coastal houses just to prevent even greater disasters. Hundreds of families were displaced, spending sleepless nights homeless, all because AGW-driven climate changes are amplifying these natural disasters.
And that leaves us with a profound, real-world question to ponder today. With the Himalayas rapidly melting, average sea levels threatening to rise a full meter, and extreme weather events increasing, what will the future of India's coastlines and millions of fishermen look like in our very own lifetime? Understanding the building blocks of climate isn't just about passing a Class 10 exam. It's about understanding the future of our planet. Keep questioning, keep learning, and thank you for joining me on this explainer.